Finishing up section 6.3 here, how can we write the expressions with a rationalized denominator? So we're trying to get rid of the radicals in our denominator here, and so we need to multiply by its complex conjugate. That's the only way that we're going to get rid of the radicals. So I'm going to keep my square root of 3 and my square root of 5. I'm just going to change the sign in the middle to be the opposite. So it's a positive square root of 3 and the opposite of a negative square root of 5, which is a positive square root of 5. Whatever I do to the denominator, I also have to do to the numerator. And again, we're doing that because we need to get the outsides and insides to be opposites so that when we combine our like terms, they cancel. In my numerator, I'm going to have 2 square root of 7 times the square root of 3. And I'm going to have 2 square root of 7 times the square root of 5. Here I can multiply these together since they have the same radicand. And I can multiply these together since they have the same index, same index, not radicands. Our radicands are different, so I multiply them together. These have the same index, both square roots, so I can multiply my 7 and my 5 together and get 35. In my denominator, I'm going to FOIL, because I have a binomial times a binomial. Square root of 3 times square root of 3. Firsts, outsides, square root of 3 times square root of 5. Insides, minus square root of 5 times square root of 3. And lasts, minus square root of 5 times square root of 5. Combine our like terms here. Square root of 3 times 3 gives me just one group of 3's. Plus the square root of 15 minus the square root of 5 times 3, 15, minus the square root of 5 times 5 gives me a group of 5's, so I have a minus 5. Now, when I combine my square roots of 15, I have positive and negative, that gives me 0. So all I have in my denominator is negative 2. Now, I can divide here. 2 divided by negative 2 just gives me negative 1 square root of 21, and 2 divided by negative 2 gives me negative 1 square root of 35. So I have negative square root of 21 minus square root of 35. Again, divided by 1, but I don't need that part of my answer because anything divided by 1 is itself. Same idea here on B. Even though we don't have 2 radicals, we have 1, and I'm trying to get rid of this radical here. In order to do that, we're going to multiply by its complex conjugate. So 3 stays, and we take the opposite of our square root of 6. So instead of being a negative square root of 6, we want a positive square root of 6. Whatever we do to the denominator, we also have to do to the numerator. Now, we're going to FOIL in the bottom and distribute in the top. So 4x times 3 plus 4x times the square root of 6 is going to give me 12x plus 4x square root of 6 in the numerator. In the denominator, again, we FOIL. So first times first, outsides, insides, lasts. 3 times 3 for firsts, plus 3 times the square root of 6 for outsides, minus square root of 6 times 3 for insides, minus square root of 6 times square root of 6 for lasts. 9 plus 3 square root of 6 minus 3 square root of 6 minus the square root of 6 times 6, which is one group, and I can take it out as a 6. Again, we want groups of 2 because we're taking square roots. 9 minus 6 is 3. And 3 minus 3 is 0. So I have just a 3 in my denominator. And since I can't take a 3 out of 4, I can't take it out of both pieces, so I can go ahead and leave it just like that. I can't reduce it any further. Real quick recap here for section 6.3. Like radicals can be combined using properties of real numbers, very similarly to how we do like terms with variables and with complex expressions. And that's all I have for section 6.3.